Hello, and welcome to the Mat3ra tutorial series. In today's tutorial, we will go through a step-by-step example of running a Quantum ESPRESSO simulation on one of our GPU-enabled compute nodes. We will see how we can dramatically improve the performance of our simulation using GPUs. At the moment, GPU build of Quantum ESPRESSO is only available via our command line interface, and soon it will be made available in the web interface. Let's connect to the login node using SSH. You can use your terminal application and type SSH, your username, at login.mat3ra.com and press Enter. If you need help on how to set up SSH, please visit our documentation site at docs.mat3ra.com and search SSH. Here you will find step-by-step guide to set up SSH key for seamless authentication. Note that it is also possible to connect to the login node from our web platform using the web terminal. Besides, it is also possible to run a command line job via Bash workflow in our web platform. Create a new workflow, select shell script as application. Add an execution unit and write your job script. For now, let's focus on the command line part. The example calculation we are going to demonstrate is available in our GitHub repository CLI job examples. Please browse under Espresso, then GPU, where you will find required input and reference output files. Once connected to the login node, let's navigate to your working directory and clone our example repository. After cloning the repository, we also need to sync the LFS objects with git lfs pull. Let's navigate to our GPU example. Let's examine the PBS job script. We will run our job in GPU-enabled GOFQ. We will request one node which has 8 CPUs. To run Quantum ESPRESSO jobs in GPUs, we need to load the CUDA build of Quantum ESPRESSO. We set 8 open MP threads and 1 MPI per GPU. We can also set parallelization options for K-point and matrix diagonalization. Finally, we can submit our job with qsub command. We can find the status of job with qstat. Once the job is completed, we can examine the output file. We will see that the GPU acceleration was enabled for the calculation. If we scroll to the bottom of the file, we will see the total time taken by the program. The wall time for this job was slightly less than a minute. For comparison, we ran the same job using 8 CPUs, but without GPU acceleration. It took about 20 times longer. Now you may test different combination of MPI and open MP threads, different parallelization option, and see what gives you the best performance. Thank you for watching this tutorial and using our platform.